Today we are going to be focusing on motion graphs. And a motion graph is when you have a distance versus time. So on one axis, which is the y-axis, you will have your distance, and your x-axis will always be time. So the first graph says you're going to move forward 10 units in 10 seconds. So that means that after 10 seconds, first off, you're always going to assume that you start at 0, 0. For these graphs. And then it says you're going to move forward 10 units, which would be this guy, and you are going at 10 seconds. All right, so then what I want you guys to do is you use a straight edge to always connect the dots, which means like a ruler or something that's straight. It's not very straight. And what I want you guys to understand that when you have a slope that does not change, you are going at a constant speed. So first off, your slope is equal to your speed, only for a distance versus time graph. Okay, so your slope equals speed. Because in this picture or in this graph, you see a constant slope, notice that it's not going up and down, it's going constant, it's not changing how fast it's going or how the rate of increase. So if you have a constant slope, what that means is that you have a constant speed. Okay, so notice that the slope is the same throughout the whole graph, so you are going the same speed throughout the whole graph. All right, the next graph, it says you move forward 5 units in 5 seconds, so that would be at 5, 5. Okay, we started at 0, 0. And then it said you move backwards 5 units in 5 seconds. That doesn't mean you're going back in time. We're still going forward in time. So if we were at 5 seconds, then we went another 5 seconds, we're now at 10 seconds. But instead of going forward, what I'm doing is I'm going backwards. Okay, so I'm going to be going back 5, which means I'm back at the origin. So we're going to connect the dots. Okay, and what I want you guys to note in this particular graph, first off, that during this period of time, so from here to here, you're going a constant speed. From here to here, you are going a constant speed. The difference, though, is where your direction is going. So what I want you to understand is when you have a positive slope for a distance versus time graph, which is this graph that we're looking at, distance versus time, a positive slope means you are going away from the origin. A negative slope means you are going towards the origin. Which makes sense because when you look at this graph, if my origin was at this thing, and let's say I'm counting tiles, and I go away 5 tiles, okay, now I'm further away by 5 tiles, and now I'm going to move my back 5 tiles, where do I end up with? I end up at the exact same spot. So looking at your distance about where I started versus where I ended, my distance actually has not changed, or my displacement has not changed. I ended where I started. Graph 3. So first off, it says I'm going to start at 0, 0. And then it says I move forward 2 units in 5 seconds. So at 5 seconds, I move 2 units. Then I move forward 6 units in 3 seconds. So instead of at 5 seconds, I'm now at 8 seconds because that's 1, 2, 3 more seconds. And instead of 2 units, I need to go up 6 more. So I'm going to add 6, which means I'm at a total of 8. So I'm at 8, 8. And then I'm going to move forward again. Notice I'm going forward, so I have to go away from my origin. 2 units in 2 seconds. So I was at 8 seconds. Now I'm going to be at 10 seconds. I was at 8 units. Now I'm going to be at 10 units. All right, so then you connect the dots. So for this graph, what I want you to understand is that you are always going away from the origin, always away from the origin. You're always moving, I guess, away from the origin. From origin. And then what I also want you to understand is that your slope is constantly changing between A, B, and C. And so that means your speed is changing between A, B, and C. So A, B, and C have different speeds. Slopes, which means have different slopes, which means they have different speeds. Okay. All right, graph 4. So now you are going to be moving forward 3 units in 3 seconds. So that's this guy. So we're at 3, 3. You're going to stand still. What does that mean if you stand still? Okay, what that means is that you're not moving anywhere. You're not going back, you're not going forward. So if I stood still, my distance would stay the same. So I was 3, let's say, tiles away from my origin, and now I stood still for 2 seconds. How far would I be away from my origin? Well, I would still be 3 units away. And then I'm going to move forward 5 units in 5 seconds. So I'm at 5 time. So I'm going to go up to 5 or to 10 seconds. And I'm at 3 units and I go another 5 units. So I'm going to end at 8 units. So I'm at 8, 10. Okay. And then once again, get out your straight edge and connect the dots. Okay. And then what I want you to note is between A, B, and C. Okay. So at A and C, we are moving away. And at B, you are standing still. So notice, what is your slope if you are standing still? If you are standing still, your slope is rise over run. What are we rising? We're going from 3 to 3, so that's a 0. Your slope would be 0. Okay, so whenever you see a horizontal line, that means your slope is 0, and that means you are standing still. All right, graph 5. So the first one, we're going to be at 0, 0. Then we move forward 2 units in 8 seconds. So we're going to go here, 8 seconds, 2 units, and then we're going to move forward 2 more units, which would be 4 total units in 2 seconds. So that would be at 10, 4. All right, so now what on this one I want you to understand is, first off, we are always moving forward. First I'm going to connect these dots. Oh, that's really bad. That's okay. And there we go. Okay, so we are always moving forward. That's key for this one. Always moving forward. Why? Because I always have a positive slope. Okay, but what I want you to note is that if I labeled this as A and this is B, A, because the slope equals your speed for all of distance versus time graphs, A has a lower numbered slope. So A is going slower than B. B is going faster. How do I know? Because my slope for B is larger / steeper. And once again, slope equals speed for a distance versus time graph. All right, the last graph. So we start once again at 0, 0. I'm going to move forward 4 units in 4 seconds. So that's 4, 4. And then I'm going to move backwards 3 units. So it was at 4. Backwards means negative. So I'm going to be now at 1 unit, and that's in 2 more seconds. So that would be 4 plus 1, 2. So that would be 6. So I want backwards 3 units in 2 seconds. And then now I'm going to move forward 4 units in 4 seconds. So I'm going to go 1, 2, 3, 4. So I know I'm going to be at 10. And then I was at 1, and now I'm moving forward. So I'm going to be positive. So I have to end at 5. So I'm going to be at 10, 5. Now I need to connect my dots. And for these parts, what I want you to really note, we got A, B, and C. A and C are moving away from the origin or the starting point. And then B is moving towards the starting point. How do I know? Because it has a negative slope. How did I know A and C were moving away from it? Because it had a positive slope. All right, hopefully you kind of understand these basic motion graphs. What I really want you to understand is that slope equals of a distance versus time graph equals your speed. I want you to note that the steeper the slope, the faster you are moving. And I want you to understand that if the line or the slope is constant, your speed is constant. If you're horizontal, that means you are standing still. If you are a positive slope, you are going away from the origin. And if you are a negative slope, you are going towards the origin, or meaning where you started from. Have a great day.